All right, in the last part of the lesson, we're going to talk about solving by factoring. So we are still following all of our factoring rules. So we just have to be able to recognize what method to use. And remember, to factor, everything needs to be on the same side of the equal sign. And then it should be set equal to 0. And then once we have it in factored form, we set each factor group equal to 0 and then finish solving the problem. All right, so if we start with 21, that one has a greatest common factor. So for this one, we can factor out a 2x, and then we would have x plus 3 left. And then there's nothing left to factor. So now I'm going to take 2x, set that equal to 0, x plus 3 equals to 0, and then I solve. So this one we would just divide both sides by 2. So for the first answer, 0 divided by 2 is just 0. Second one, we're subtracting the 3 over. So then that would give us x equals negative 3. So our two answers would be 0 and negative 3. And remember, when we're solving by factoring, we're finding the zeros of our function. So we're finding the places where our graph is crossing the x-axis. Okay? So these represent the two different places where it's crossing the x-axis. Our problem 22. So this one, we need to start by subtracting the 1 over. So we're really going to factor 8x cubed minus 1 equals 0. Now this is going to be the difference of cubes. So that means that we're using the pattern a minus b times a squared plus a times b plus b squared. So a is the cubed root of the first term, so that's going to be a 2x. B is the cubed root of the second term, so a 1. And then we're just substituting it into this form. So our factored answer is going to be 2x minus 1 times, again, we're squaring the quantity of 2x. So that'll become 4x squared plus, and then 2x times 1 is 2x. And then b squared, so 1 squared is 1, equal to 0. Now we know that this is prime, so we are setting 2x minus 1 equal to 0, and then 4x squared plus 2x plus 1 equal to 0, and solving each. So for this one's easy. We add 1 and then divide by 2. So our first answer is 1/2. Now on this one, since it's prime, the only way to solve it is either by completing the square or the quadratic formula. And because we have the number in front of the square term, I'm going to choose to use the quadratic formula. So that is x equals negative 2 plus and minus the square root of 2 squared, so 4, minus 4 times a times c, all over 2 times a. And then we're just simplifying this as much as we can. So this is going to be negative 2 plus and minus the square root of something over 8. So here we would have 4 minus 16. So 4 minus 16 is going to give us a negative 12. So now to keep simplifying this, sorry, I'm running out of room here. This would be negative 2 plus and minus, and we're splitting that as 4 and 3. So 2i square root of 3 over 8. And then we can divide the negative 2, the 2, and the 8 by 2. So our second set of answers is going to be negative 1 plus and minus I square root of 3 over 4. If we divide all of those by 2. So our final three answers. All right, so if we continue, next set. Okay, so everything's equal to 0. It's a quartic with no greatest common factor. So that means that we have to figure out what is going to multiply to be 11, add to be negative 12. So we would choose a negative 11 and a negative 1. And then this would split as x squared and x squared. And this one I can keep factoring. So this will factor into x plus 1 times x minus 1. And the other one, 11, is not a perfect square, so that one we cannot continue factoring. So now again, we're just setting each group equal to 0 and solving. So for this one, we're going to add the 11. And then because there's a squared, we have to take the square root of each side. So our first set of answers is going to be plus and minus the square root of 11. Second one, we would subtract 1, so that'll give us x equals negative 1. And then our third group, we would add the 1 to get positive 1. So here are the 4 final answers. All right, next one, since everything's not on the same side, we need to start by subtracting the 3x squared to each side. And make sure that you put it in the right spot, otherwise it might be difficult for you to figure out how to factor. So this needs to go in between those two terms. So we're really factoring x to the 4th minus 3x squared minus 10 equals 0. So again, we have a quartic equation with no greatest common factor, missing our cubic and the x term. So we're factoring this just like a quadratic equation. So the first term gets split as x squared and x squared. And then two numbers that multiply to be negative 10, add to be negative 3, will be a negative 5 and a positive 2. I don't have the difference of squares for either of these, so we can't factor any further. So now we can set each group equal to 0 and then finish solving. So for this one, we're going to add the 5. And then to get rid of the squared, we have to take the square root of each side. So our first set of answers is going to be plus and minus the square root of 5. Second group, we are going to subtract the 2 over, so it becomes negative. And again, we're taking the square root of each side. So if we simplify that radical, it's going to be plus and minus I square root of 2. So here are the final 4 answers. All right, the last 3 examples I'm going to do in the next video.